Hello guys, welcome back. If you haven't seen my introduction video, here's gonna be a link for it. And today we are gonna focus more on the code, but not in the way of coding, more code refactoring. It's because you can imagine that it might happen that you will be assigned to a task in order to check machine or add some functionality to it. It doesn't mean necessarily you have to write the code from the beginning. So it's like a little bit different approach. I hope it will be beneficial. So yeah, let's get it started. Go straight to our task. Just started factory.io. I'm gonna open our scene, pick and place. Okay, I have a code prepared. Gonna start the instance of control.io. Starting. There we go. Open. Yeah. So today we would like to achieve something like this. Let me go back. I'm gonna start the simulation. Start the system. Yeah, so basically that's the goal for today. What we can see is that after pressing the start button, conveyor is running. Then when the parcel reaches the peg location, the conveyor stops, and our machine grabs the item and goes up with it. So let's have a look at our code. So that's how it looks. What's a nice thing that we have some comments. So here is a start condition. Here is condition for our entry conveyor. Move on the Z axis and grab and move Z actuator. So let's go one by one. Started condition. So let's think a little bit about it. Here we have those two buttons, start and stop. So obviously when we start the system we would like to be able to stop it as well. So best way how to do it is to create some memory bit, as an example started, and later before setting any output we would like to check the condition if the system is started or not. So let's have a look. The outputs are in the red color. So we have the entry conveyor, we have condition end. Yes, we are checking if the system is started. We have condition to move, but that's a memory bit. Let's go further on. Yeah, here we have output. So let's go backwards, because that's basically how we would like to work, going from the output to the conditions. So we're gonna go from the output, move on Z axis. We go to the memory bit. Here we go backwards. We check, do we have a started condition? Yes, we do. It's on the AND gate, which is correct. And we can see that here for the grab an item, we don't have any started condition, which means that it's most probably first of the bugs that we have found here. Or not necessarily, because what's gonna happen when we are gonna have started here? Let's have a look. So I'm just gonna add it in here. Okay, let's go back to the system. Gonna reset everything. Start the system. Our started bit is high. Yes, it's high. We can see by this color here, and those two dots are fully blue. Now I'm gonna stop the system. Oh, and the item has dropped. Yeah, that's not necessarily what we would like to have. That's why the first impression we had, yeah, as I said, in every case looking at the output we should check if we have a started bit. Yes, that's correct, but as always we have some exceptions. So that's why let's go to the previous state. Start the system. Okay. Up. System is stopped, but we still have an item on our machine, so that's good. So it's important to think more about those conditions. It's not always so straightforward that we have an output and we have to check if the system is started. In most cases that's true, but not always. Now let's go one by one. Let's have a look at the started condition. We can see that we have start and stop button. Stop button, we had to put a NOT gate. It's because stop normally is as a normally closed, which means basically it's inverted. Reason behind this is that if it would be as a start button, which means that it would be normally open, yeah, let's say we would cut the cable in the cabinet, and then after pressing the button we won't be able to detect because we wouldn't have any signal. Now if someone cuts the cable of the stop button, we are gonna have instantly the stop command. So first look here, what could be wrong in this code. Best idea to check is to create some testing bits. We can do it quite quickly here. This is gonna be our start, our stop, and as an output I will put some memory bit. Okay, start this. Okay, I'm gonna just set. Okay, I have started. Let's say reset. Everything is fine, but let's imagine what's gonna happen if someone's gonna stick something into the start button and it's gonna be pressed constantly. It can happen, and we would like to stop the system. Nothing happens, so there's something wrong. Why? Because we are using set reset. The priority here has a set, so that's why we have the output set all the time. So if we're gonna exchange it for reset set, then we should be able to stop the system because the priority is on reset instead of set. Let's have a look. Normal functionality works same. I'm gonna hold the start button and press reset. Yeah, and now the output started is reset. So I would say that's the first thing we would like to exchange in here. And now we should have a desired behavior. That's it for today. Thank you for your attention. If you have any comments or remarks, please let me know. And in the next video we're gonna focus on the rest of the code for the step 1. See you next time.